Okay, dear students, in this slide, we will try to learn how you will predict that in which direction the pointer of the galvanometer will deflect. Here, this is one example. You have a solenoid, and this solenoid is connected with the galvanometer. And when there is no current in this solenoid, the pointer of the galvanometer will be in the center. Here I have a permanent magnet. Its north pole is facing the right side of the solenoid, and this permanent magnet is moving towards the right side of the solenoid. According to the Lenz's law, this side of the solenoid, it will become north pole, and this side will become south pole. Why this will become north pole? So that it can repel this north pole, so that it can oppose this approaching north pole. To stop this approaching north pole, on the right side of the solenoid, a north pole will be induced to stop it. Once you know that this side will be the north and this side will be the south on the solenoid, then use the right hand grip rule for the solenoid. Hold this solenoid in your right hand in such a way that your thumb is pointing towards the north of this solenoid. So I will hold this solenoid in my right hand in such a way that my thumb is pointing to the north of this solenoid. So you see the curls of my finger, they are telling me the direction of the current. So the side of the solenoid which is facing me, uh, in these wires, the current will be according to the curls of these fingers of my right hand. So on these wires, when they will be put arrows in downward direction according to the right hand grip rules, because they are following the direction, the current is following the direction of the curls of my finger. So when I put the arrows like this, so I know that in this wire the current is going down from here. From here I will put an arrow here, so current will be going in this direction. So when you put arrows, then you will came to know that the current here is flowing from right to left, so that the pointer of the galvanometer will also point towards left. I hope that you have understood that how I have predicted the direction of the current induced in the solenoid, and how I predicted the deflection in the galvanometer. Let's consider another other example. So here I have another example. Here again is the same situation. I have this solenoid, and in the solenoid is connected with the galvanometer. When there will be no current induced in the galvanometer, the pointer of the galvanometer will be in the center. The pointer will be in the center. Here I have a permanent magnet. Its north pole is facing the right side of the solenoid, and this magnet is moving away from this right side of the solenoid. Its north pole is facing the right side of the solenoid, and it is going away, it's withdrawing. So to stop this north pole from going away, on this solenoid, on the right side of the solenoid, a south pole will be induced, because this south pole will try to attract this north pole, and it will try to stop it. That's the Lenz law. It will, the magnet which will be formed on the solenoid will be in such a way that it will try to oppose the motion which is inducing it. So this north is going away. To stop this north from going away, the right side of the solenoid will become south pole, and then this side will be obviously north pole. Then if you want to predict what will be the direction of the current induced in the solenoid, use the right hand grip rule. Hold this solenoid in your right hand in such a way that your thumb is pointing towards the north pole. So I will hold it in my right hand in such a way that my thumb is pointing towards the north of this solenoid. The north is on the left side of the solenoid. Now you see, I the current in the solenoid, the current which is induced in the solenoid will be following the curves of my finger of the right hand. So according to the curves of my finger of the right hand, from the side of the solenoid which is facing me, the current should be going up, and from the other side it should be going down. So what I will do, I will put arrows in upward direction on these coils which are facing me. So it means the current is going up in these coils. So it means the current is going up. It means the current is coming in this direction. And from the other side, you know, the current is going down. So I came to know what is the direction of the current. So according to these arrows, I know that the current is now flowing from the right, from the left to the right. The current is flowing from the left towards the right. So the pointer of the galvanometer will also point towards the right. I hope that you are able to understand that how I am able to predict the direction of the induced current in the solenoid, and I am also able to predict the deflection in the galvanometer. Okay, let's move to the next slide. Here we have a little same kind of situation, but little different. Here I have a solenoid, again same coil, solenoid connected with a galvanometer. The pointer of the galvanometer will be in the center when there will be no induced current in the solenoid. Here I have a permanent magnet, and this permanent magnet's south pole is facing the right side of the solenoid, and this permanent magnet is moving towards the right side of the solenoid. According to the Lenz's law, if a south pole is approaching the right side of the solenoid, the right side will become south to stop it. And when this side will become south, this side will become north. So apply the right hand grip rule on the solenoid. Because I know it's north pole, I will hold this solenoid in my right hand in such a way that my thumb is pointing towards the north of the solenoid. So when I will hold it, my thumb is pointing towards the north of the solenoid. So you know, the curves of my finger, they are showing the direction of the induced current. So the curves of my finger are showing that the side of the solenoid which is facing me, in those coils the current will be going upward, and from the other side the current will be going downward. So I will put arrows in upward direction here, and when I will put arrows here, so I will came to know that the current is going in this wire in upward direction, so current is going this. So complete these arrows. So when you have put these arrows here, then you know that here the current is flowing from left to right. The current is flowing from left to right. So the pointer of the galvanometer will also point towards the right. I hope that you have understood that how I predicted the direction of the induced current and how I am able to predict the deflection of the galvanometer. Let's move to the next slide. Okay, dear students, here again we have the same kind of situation. Here I have a solenoid, and that solenoid is connected with the galvanometer. And when there is no current in the galvanometer, the pointer of the galvanometer will be in the center. Here I have a bar magnet, and its south pole is facing the right side of the solenoid. When I will move this bar magnet away from the right side of the solenoid, you know, this south pole is going away. We are withdrawing it. It's moving towards the right. So this south pole, when it's going away, to stop this south pole going away, here a north pole will be induced, and here a south pole will be induced. When this north pole is induced here, uh, the reason is the Lenz's law, because the induced polarity will be in such a way, it will try to oppose this motion. because the south pole is going away. To stop this, here a north pole will be induced. It will try to attract this south pole and it will try to stop its motion. Once you have decided that the right side of the solenoid is north and the left side of the solenoid is south, then you can apply the the right hand grip rule for the solenoid. So I will hold the solenoid in my right hand in such a way that my thumb is pointing towards the north. Okay, so this thumb is towards the north of the solenoid, and the curls of my fingers, they are telling me the direction of the induced current. So the current is in this way. The side of the solenoid which is facing me, the current will be going downward. So in these coils, I will put arrows in the downward direction. So if in this wire the current is going down, when I put this arrow, then I will put this arrow, then I will put this arrow. So I know the current is coming in this direction. So current is going that, so I will put this arrow, this arrow. So now here I know that the current is going from the right side to the left side. If the current is going from the right side to the left side here, the pointer of the galvanometer will also point towards the left side. So I hope that you are able to predict that how you are also able to now predict the direction of the induced current and the direction of the deflection of the galvanometer. Okay, here we have another example, and in this example you can see same solenoid. It's connected with a galvanometer. The pointer of the galvanometer will be in the center when there is no current in the solenoid. And here I have a bar magnet. Its north pole here, and the north pole is facing the left side of the solenoid, and it is approaching the left side of the solenoid. You know, when this north pole will try to approach the left side of the solenoid, according to the Lenz's law, the pole induced on the solenoid on the left side will be north and on the other side it will be south. The reason is, how do I know? Here we will have a north pole. The reason is, it will try to oppose this approaching north pole. It will try to stop this approaching north pole. This north pole is coming near it. So here we will have a north pole. It will try to repel it. It will try to stop it. Once you have established that this left will be the north pole, this right will be the south pole, then apply the right hand grip rule for the solenoid. Take your right hand, hold the solenoid in such a way that your thumb is pointing in the direction of the north of the solenoid. If and then the curls of your finger, they are telling you the direction of the current. So the curls of my finger are telling me that the side of the solenoid which is facing me, the current will be going in the upward direction. So in these coils, I will put arrows in the upward direction. So I know if I put this arrow upward, so here I will also have an arrow upward, so current is going up. So here I will put this arrow, and then I will put this arrow. It means here the current is going from the left to the right. So this galvanometer pointer will also deflect in the right direction. So I hope that you have understood that how I am able to predict the direction of the induced current, and how I am able to predict the direction of the deflection of the galvanometer pointer. Okay, here is another example. Here you see I have the same kind of situation. We have a solenoid. Here I have the galvanometer. The pointer of the galvanometer will be in the center. When there will be no current in the galvanometer, the pointer of the galvanometer will be pointing in the center. Here we have a bar magnet. Its south pole is pointing, its south pole is facing the left side of the solenoid, and this is approaching the left side of the solenoid. So a south is approaching the left side of the solenoid, and when this will happen, the current will be induced here, and an electromagnet will be induced on the solenoid. On the left side, a south pole will be induced, and on the right side, a north pole will be induced. How do I know that here a south pole will be induced? Because this south pole is approaching this side of the solenoid. To stop it, to oppose this motion, to oppose the approach of this south pole, here a south pole will be created. Here a south pole will be induced. This south pole will repel this south pole. This south pole will try to stop this south pole, which is trying to come near it. So once you have established that which side of the solenoid is north and which side of the solenoid is south, then you will apply the right hand grip rule. Hold this solenoid in your right hand in such a way that your thumb is pointing towards the north of the solenoid. Hold it in your right hand in such a way that your thumb is pointing towards the north of the solenoid. If this is the north of the solenoid, then the curls of my finger are telling me the direction of the induced current. The curls of my finger are telling me the direction of the induced current. And they are telling me that the side of the solenoid which is facing me, in that side, the current should be going downward. The current should be going downward from the curls of my finger. I know that. So on this diagram, on these coils, I will put these downward arrows. So if I put a downward arrow here, I will put a downward arrow here. So here the current is going in this direction. It means the current is going in this direction. Put this arrow. So the current is going in this direction. Put this arrow and this arrow. So here now I know that the current is flowing from the right towards left. Once you know that the current here is going from right to left, so the pointer of the galvanometer will also deflect towards left. So this pointer will be deflected towards left. So my dear students, we have at least considered 6 examples in which I tried to explain to you that when you move a bar magnet near a solenoid connected with a galvanometer and no source of electric energy, when you move the bar magnet, electricity is induced in this solenoid. EMF is induced in that solenoid. And by using this procedure, which I taught you, which I tried to explain to you, with this procedure, you can predict the direction of the induced current, and you can also predict the direction of the deflection in the galvanometer. I hope that you have understood this. It's very important. This prediction of the direction of the current and prediction of the direction of the pointer of the galvanometer, this comes in theory paper. This also comes in your MCQ paper. So I hope that you have understood it. Thank you very much.